Hey, welcome to your practice test. I hope you've actually done some revision ready for this test, because not much point in trying to practice something that you haven't revised. So here we go. Let's have a look, and I'll go through the test question by question. A total marks 47, so you're going to take probably about 50 minutes or even a bit more to do this test. So come on down now and let's look at the first question. There it is. So pause the presentation and have a go. All right, 5 marks for that one. Let's go on now to the next question. We'll just go a little bit more quickly than that perhaps. Coming down here. Come down a bit quicker. There we go. So coming down to question 2. No, sorry, it's the rest of that one. So I want you to put the answers that you had up above on that table. So copy the table down, and then to plot the points there, 1 mark for the table and 3 marks for plotting them. So do it accurately. Right, pause it and have a go, and go to the next question. Question 2 is a factorisation question, a few parts there. So pause that and do A and B, and then I'll show you D and E. So there's D and E, all 2 mark questions. Okay, pause it and have a go. Let's go down to the next question. Question 3. This time factorising and then solving it. We're using the null factor law. So 2 little questions there. And then coming down to the last one in that set. Each of these is worth 3 marks, a fair bit of work to do for each of them. Alright, coming down then to question 4. A fairly big question. We ask for the y-intercept and the x-intercepts, and then sketch the function. Then let's go to question 5, labelling the graphs. Okay, and then to question 6, a puzzle type question. Okay, and final question is question 7. So these last few are worth 5, 6 or 7 marks. Alright, well, once you check your work and then keep rolling the video, we'll pause it now, check your work, then roll the video, and we'll go back to the beginning and you can watch me do it. Here we go. So going back to the beginning. Right, let's start this one now. So you want to put your name on it. So here we are, honey, put my name in there, and then we're going to come down and have a look at working these out. So in part 1, I'm going to put x equals -2 in the formula, so y will equal -2 squared, putting it in place of x up here, plus -2 take 2, so that's going to come to 4 take 4, which is 0. You get that one? Okay, part 2, putting in x is 1, so y would be -1 squared, take 1 take 2, which is going to be -2. It's 1 take 2, which will be -2. Check that out. Moving to question, or part 3, putting in x is 0, y will equal just the number down the end. And then in part 4, putting in x is 1, it will be y is 1 squared, plus 1 take 2, which will be 0. And we'll sneak. We'll just come down a little bit, and then we'll sneak part 5 in here. When x is 2, y will be 2 squared, plus 2 take 2, which is 4. Now we have to put those on a table over on the next page. So all of these were, of course, worth 1 mark each. 1, 2, 3, 4 and 5. So mark your work. It's out of 5 there. So come down and let's have a look at this next little part of this question where we had to fill in the table. And here comes the table. Okay, so what did we find here? We found when x is -2, it was 0. When x is -1, it was -2. When x is 0, what did we find? When x is 0, we had -2. And when x was 1, y was 0, x was 2, y was 4. So we need to put these on the graph now. So let's have a look. Neg 1, neg 2, 0, 1 and 2. Well, a bit crowded. You could have actually expanded a bit this way. And then the values were, so we'll just come down a bit to get enough room. So when y was, just come up here just a little bit, oops, in here. When x was neg 2, y was 0, so we've got a point there. When x is neg 1, y was neg 2, a point there. When x is 0, y was neg 2. When x is 1, y was 0 again. When x is 2, it was up at 4. So let's just drop this down a little bit so we can see the picture now. So we need to draw a graph coming through there, and the vertex or the peak of it with a little bit off to one side, and so it's going to go like that. That should be smooth in there. Okay, so let's just try and do that better. Okay, a parabola. Okay, so it's 3 marks here. So first of all, it was 1 mark for back up at the top here. Back up there, 1 mark for that. So you're allowed 1 error without any penalty, but after 1 error you lose that mark. Coming down here now, we've got this graph for 3 marks. So we want to get these two correct. That's only 1 mark, and these two correct, and then 1 for the shape. Okay, basically a parabola type shape. So these two 1 mark, these two 1 mark, and the shape. So mark your work out of 3, and how you're going. I hope you're getting a few marks there. Let's go down now and look at question 2. Here we are, fully factorised. So these right as a product of factors. So what will go into 2x squared and 14x? That's a 2x. What do I multiply 2x by in here to get x squared? I need another x. Plus what do I multiply 2x by in here to get 14x? I need a 7. So that's our answer. For 2 marks, that's 1 for the 2x out the front and 1 for the correct bracket. X squared take 9, you might recognise this as x squared take 3 squared, which means it's a squared take b squared, which is a plus b by a take b. 1 for each of those brackets then. Just coming down here, x squared plus 6x take 7, you might recognise that as a FOIL type problem, and so here 7 is plus 7 take 1, 2 numbers to multiply together to give neg 7, and the winning number has to be positive, so the larger size number, here the 7 must have been positive. So you're just doing a checking of FOIL there. Okay, 1 for each bracket. Let's go to the next one, a similar problem, and here x squared plus 20x plus 100 fits the usual pattern of FOIL, x by x, and numbers multiply together to give 100. Probably won't want to go through all of them because 10 tens, you might spot that straight away. Otherwise you'd put 100 by 1, 50 by 2, divide by 3 doesn't go, divide by 4, divide by 5, and keep going up to 10. But we'll hit it here at 10, so this is going to be positive and positive, but it gives you 100. And 10x and 10x gives you 20x. So again, 1 for each bracket. And how you're going, I hope you're getting a few marks there. Clearly in this one, you might have just gone straight to, if you were smart enough to see it, a perfect square. Alright, let's keep going now and have a look at question 3. We're going to use the null factor law to solve this. That's one more step. So we'll need to factorise it. So put in implies. What goes into both of these? Oh, that should be a minus there. What goes into both of these? 3x. And 3x by x is 3x squared. Take 3x by 4 would be 12x. So by null factor law, the product is 0. if one of the factors is null. Either that is null or 0 or this is. So this implies x is 0 or x is 4. So two answers there. So it's one for the correct factorising and one for each of the answers. So how did you go with that one? Just come down a bit, we don't want to go down that much. So this one looks like a perfect square. Why? Well, 4x squared is 2x all squared, take 5 squared. So we could say that's 2x plus 5 by 2x take 5 using factorisation. By the null factor law, either this one is 0 or this one is 0. So that means 2x equals negative 5. That is, x is negative 5 over 2. Or 2x equals positive 5. So x is 5 over 2. Only 3 marks, bit more work there. One for the correct factorising and one for each of the answers. Hope really some marks there as we go. So these are the more theoretical questions. So in this one we want to solve with a null factor law. So we're going to have to get all terms on one side, because the null factor law has to do with equations being 0. Let's move that 10 across. Let's divide everything both sides by 2. So we're going to have that dividing each of the numbers by 2. We're now ready to use the FOIL approach, factors of 5. So I think you'll see plus 5 and negative 1. The bigger one must have been positive because the overall number of x's is a positive number of x's, and yet you've got a negative product here. So the product of these two had to be negative. Alright, so by the null factor law, the first factor is 0, or the second factor is 0. So x is negative 5, or x is 1. So again, one for the factorising and one for each of the answers there. How are you going? Hope you're enjoying yourself. Hope you're getting some marks. So here is question 4. So this is a fairly big question, fairly important question too for quadratics. Let's do the first part. The y-intercept is when x equals 0. Let's put x equal 0 in the formula. It's 0 squared, take 14 times 0 plus 48. So y is 48. So the point is 0, 48 there on the y-axis. In part 2, the x-intercepts are when y is 0. So we've got x squared, take 14x plus 48 equals 0. So now we want factors of 48 to give 14. So we could go 48 and 1. You could go through the process. 24 times 2, 16 times 3, and 4's into it, 12 times 4. Haven't hit anything yet until we get down to 8 times 6, and that seems to be the one that we want. If we had neg 8 and neg 6, we would have plus 48, and we would have neg 14x, so it works. Let's just bring that back again. Okay, so just, hang on, we'll just slip down a bit there, so let's come back there. Okay, so either x take 8 is 0, or x take 6 is 0. So x is 8 or 6. So there are 2 x-intercepts, 8, 0 for y, and 6 there with 0 for y. Right, now we've got to clearly label these features. So let's go down, and we want to make a pretty good graph. It might be easier for you to do this than I, because on the screen, of course, it's hard to draw straight lines and stuff, but we'll try. So we'll put the axis right over this side now, right over there, because we know the x-intercepts are 6 and 8. We'll put it right up here because the y-intercept is neg 48. So now we have our axes, x and y, and the origin here. So here we are, 6 and 8, so let's go. Let's call 1, 2, 3, 4, 5, 6, 7, 8. So 6 is here, and 8 is here, and they are our y-intercepts. And I think I've already made a mistake, because if I remember rightly, it's plus 48, not neg 48, so I've made it, so it's neg 48, so I'm going to have to move my axis way down the bottom here, so that I can get 48 going up along the y-axis without running out of room. So here we are, do it again, 1, 2, 3, 4, 5, 6, 7, 8. So we might label it there, and that's 5, and 6, so that's our first point, and 8, and we've got to go up 48 up this axis, so we've got to go up in tens, 10, 20, 30, 40, and that's 50, so 48 is there. So we've cramped it down a bit, so we've got a graph that is actually looking, like this. So we've got to go back up again here. I've just messed that up. So here, up through there. And it's a bit distorted because I've changed the scale on the y-axis. Right, so how would you mark one of these? There are a total of 7 marks. So let's go back up to where we have our working out. So here, what? I think there's 1 mark for that, and 1 mark for the factorising. So just come up here. There's a little bit more. So 1 mark for the factorising, and 2 marks here, so that's 4 so far. Then if we come down to our graph, what we want to see is the right label on the axes and the scale, all for 1 mark, and then these points for 1 mark and 1 mark for there. So the actual graph would be out of 3, with the other 4 marks coming from above. Okay, so what do you think about that? How are you going? Hope you're doing well. Let's go on now and look at the next question. So we just come down, without skipping too much, we're doing a bit of skipping. Very tiring skipping. Match the following functions with the graphs labelled below by putting a letter next to each graph at the end of the arrow. So let's see if we can find this dude. First of all, it's positive here, so it's concave up, and we notice its vertex is 2, 1. So 2, 1 we want to find. There's 1, and that's it. 2, 1, and it's concave up, so this is A. Let's see if we can find the next one. Again, it's a concave up one. Going to go like that. And its vertex is at neg 1, neg 2. Okay, so come across here. Neg 1. Oh, neg 1 is there, that's neg 2. Neg 2, so it's the purpley one or pinky one in there. So that's part B. It's quite good fun, isn't it, I think, to do these. We'll just go back up again a little bit because we've lost that function. Well, look at this one. This is a negative, so it means it's concave down, and its vertex is at neg 2, opposite sign of that one, remember, neg 2. So, oh no, there are 2 of them there. Look at them, 2 of them both opening downwards and with the vertex at the same point. So we've got to compare the next one. Oh yes, neg 2, 3 would be its vertex. Opening downward, what's that 2 going to do? The coefficient there, of course, always makes it steeper, so just bring that back up. Can't touch the screen here when you're writing on it. So this is a steeper one, isn't it, when there's a number in front? So that's the lighter one there, the bluey one. So that's part D. And part C, the greeny one, is the one that's not so steep. So this is less steep than this one. So C is the sort of flatter one there, and D is the bluey one. Okay, so 1 mark for each of those for those labels. Okay, you can only get a mark for the ones that were correctly labelled. Let's have a look at this question now, and we're into problem solving. We've done the basic idea of things, now we're into problem solving. So let's have a look at question 6 then. So here, question 6, a number is decreased by 2, divided by the original number, the answer is equal to 2. Okay, let the number be x. So a number is decreased by 2. Let's do that first. Decreased by 2. X take 2. And then divided by the original number. And the answer is they were equal to 2 less than the number. X minus 2. 2 less than the number. So by actually underlining all these things, we make sure we've covered all the facts. Now we've got to look at how to solve it. So we have a denominator. Our common method in mathematics in solving equations with denominators is to multiply put through by the lowest common denominator. So we're going to multiply each term by x, so we'll cancel there, and then we'll go and multiply this other side by x. Okay, then we can say x take 2 equals x by x squared. X by negative 2 is negative 2x. Now I'd like to keep the x squared positive, so let's move the 2 across, add 2 to both sides. So if we added 2 here, we get wipeout, and we've got to add 2 on that side as well. Then if we want to use the null factor rule, we'll have to take this x away, and we'll have to take an x away from this side. So it'll be negative 2x take x is negative 3x. Hope you remember that. If you're down here at negative 2x, you take another x, you'll be further negatively down to negative 3x. So now we need to simplify this. So this is a factorisation again. So 2 numbers multiplied together give 2, neg 2 and neg 1. Why do I know it was negative? Because you had to come out with a negative answer there. So 2 negatives times gives that positive. Alright, so now we can say by the null factor rule, either that factor is null or 0, or this one is null or 0. So therefore x equals 2 or x equals 1. So there are 2 possible numbers. Don't leave your answer in x's. 2 possible numbers are 1 and 2. And you could check back in the original up here and see if they worked. We've got 5 marks there, so I think we could have a few more marks. I think there'd be 1 for the correct expression, 1 for multiplying it correctly across and getting that, 1 for getting all terms on one side, and 1, oops, hang on, we've lost it again here, so we'll just come back and come up again. And we've gone to a smaller size here, so that's no good. We'll come back and we're almost there down to here. Alright, so this is getting better. We need to just come across a little bit. So we'll bring this across, move on, and just come across here a little bit. Alright, so we're marking this at the moment, that went wrong. So we've got so far 3 marks, and then we'll have 1 for this and 1 for stating the answer. Okay, I don't know what's happening there. So 1 for stating the answer there. So let's go back to our pens and see if we can make them work. that's better. So sorry about all those glitches there. And so we've got 1 and 1 meaning a total of 5. So let's just look at that mark scheme again. So 1 for the expression there, 1 tick, 1 for the correct expansion, and then the other 3. Let's look at the last question. In this figure, we've got that information, B equals BC, not a bad idea to underline it. CD is 3 centimetres more than twice the length of BE. Ooh. Okay, find the length of BE. So let BE equal X. And now let's get all this other information in terms of X. So BE equals BC, so BC will also be X. And CD is 3 more than twice BE, so twice BE is twice X plus 3. So this is crucial to get this set up. So now I think you can probably see a method of doing this because of, let's go slowly here. So because of this figure. So in this figure you can see 2 similar triangles. Triangles ABE and ACD are equiangular, they have the same angles. Now in this sort of problem, we haven't been asked to show it, we're going to use it, we have to say they're equiangular, that angle is common to both, and that's a 90 and that's a 90. And the others must by some angles of a triangle be equal. Some angles of a triangle must always equal 180. So once we've said that, we can say BE. How do you know to start with BE? Well, BE is what they asked for. Excuse me, so BE to CD will equal another pair, AB to AC. Remember, it's a side in the object triangle compared to its match in the big one in each of the cases. So now that we've got that, can we work in some of the stuff we had before? So BE is X, CD is 2X plus 3 from above there, and AB, now AB is a bit of a trick because AB was given to us as 10. We've got to use that 10. Just remember, one of the tricks in problem solving is use all the given information. So AC is 10, and AB is 10 take X. Let's just go back and check that now. So AC was 10, and AB therefore is 10 because this was an X, so 10 take X. So that's a little bit of a trick there to get those. Now what we need to do is to get rid of the denominators. So the common denominator that we'll multiply by is 10 times 2x plus 3. And if we multiply it up here, the 2x plus 3 would cancel. We're left with 10x. And if we multiply it over here, just writing in, see it more clearly, we'd be left with 10 take x by 2x plus 3. So you can see we're going to get a quadratic here again, but this time quite a complicated process to get it. So let's do the 4 on the right hand side. That's 20x plus 30, take 2x squared plus take 3x. Okay, so now we have to, with the null factor law, get all terms on one side. So let's leave the 10x there. Let's add 2x to both, 2x squared to both sides. And 20 take 3x is 17x. On that side, so we'll take it away and bring it over here. And then we'll take 30 as well. We're getting all terms across to the left. And we've got a positive x squared term. So that's good because it's easier to work with in factorising. So now our answer here is 2x squared. 10x takes 17x is neg 7x. Take 30 equals 0. So the factorisation isn't that friendly because we've got to have a 2x and an x. to get 2x squared from 4. Now we do numbers in here, such that when they multiply by 2 and 1 respectively, they give us the right middle term. So we could try it again, 30 and 1, 15 and 2, 5 and 3. We'll stop there. Now, we want negative 7x. So you can try 5 and 3 in these two spots. One's got to be positive, one's got to be negative, because when times together, the number down the end has to be negative 30. So if you try that, you'll find take 5 and plus 3 works. That gives you negative 10x plus 3x, which gives you a negative amount of x's, which is, excuse me, negative 7x. So now, of course, we can say here that 2x plus 3 is 0, or x take 5 is 0. So that means subtracting 3 from both sides, 2x is negative 3, or x is, hang on, let's watch this here. Yep, so x is negative 3 over 2, or x is 5. So will that work? Yep, so here the numbers are, we won't have that one because discard because x is greater than 0. This one is correct, so that means BE is 5 centimetres long, and that's what they asked us to find. Alright, so how did we mark this one? It's quite a big question. There are 5 marks, so I think the first thing is to get this information, that's 1. Then to say they're equiangular and similar, 2. 3, I think we really deserve more marks for this one. And then finally 4, and with the answer down here 5. So really I think that deserved more marks, but not to worry, that's not too bad. Okay, so let's have a look then at what marks you got. So go up the top and put a total there. Where are we here? Let's go right up to the top and put a total out of 47. So I hope you did well there and see what you thought. Okay, alright, so I hope you enjoyed yourself. Make sure you follow up the ones you weren't sure of so that you can do better in the proper test. So cheers for now.